In this section, I'll discuss multi-user MIMO and how it works with 802.11ax. With 11ax, we need both OFDMA and multi-user MIMO. Each has its strengths and weakness. Single-user MIMO, or SU-MIMO, was introduced in 11n. It increases Wi-Fi speeds by allowing a pair of wireless devices to simultaneously send or receive multiple data streams. Multi-user MIMO was introduced in 11ac. It theoretically allows multiple frames to be transmitted to different receivers at the same time and on the same channel using multiple spatial streams to provide greater efficiency. For 11ac, it was only available on downlink. With 11ax, it will work on both uplink and downlink streams. In MU-MIMO, if I have a 4-stream AP like our R720 or R710 and a 4-stream laptop, I can transmit all 4 streams at the same time. However, today, this 4-stream laptop doesn't exist. There are no client devices with 4 streams. By using MU-MIMO, I could have a MacBook Pro or smartphone that has 2 streams and other clients with 1 stream each. MU-MIMO allows me to split the streams. I can send 2 streams to my MacBook Pro, assuming it has MU-MIMO capability, 1 stream to an older smartphone and another stream to a tablet client. In multi-user MIMO, I am splitting the streams. This is very different than single-user MIMO. Everybody is getting 80 MHz, for example, but they are splitting the stream. In OFDMA, they are getting different chunks of the spectrum, which are divided up into resource units, or RU tones. So the question comes up, when do I use OFDMA and when do I use multi-user MIMO? This chart shows the strengths and weaknesses of both technologies and when to use them. These are 2 complementary multi-user techniques to serve multiple users concurrently. Sounding overhead. With multi-user MIMO, I need to know where each client is so I can talk to them in 2 different directions simultaneously. To do this, the AP needs to do some work to figure out their locations. This is accomplished through sounding. The sounding process takes about 1 millisecond, which is a long time in the Wi-Fi world. If I spend 1 millisecond trying to figure out a client's location, I need to have at least 10 milliseconds to transmit my data to get the benefits of using this sounding time. If I do all this work for 1 millisecond and then transmit 100 microseconds of data, it doesn't make sense as my overhead is too high. So if I use 1 millisecond to set up to talk and use 10 milliseconds to transmit, that's where multi-user MIMO becomes very efficient and useful. What this means is that I need to have a lot of data to transmit. So when there is a lot of data to transmit, such as downloading a large video, multi-user MIMO is very useful. With OFDMA, there is no sounding overhead for either downlink or uplink OFDMA. I don't care where my clients are. I just allocate a chunk of spectrum, so there is no concept of sounding in OFDMA. Transferring data. What does this mean? If I break a big truck into smaller trucks, which means that I'm transporting little boxes or small amounts of data, OFDMA is very applicable. For example, if I have a bunch of phones doing Wi-Fi calling, I'm better doing OFDMA. It doesn't make sense for me to do multi-user MIMO to those clients because I only have a small amount of data. But if 10 clients are downloading 4K movies, I'm better off doing multi-user MIMO to those clients. 2 different scenarios, 2 different use cases, both useful. Number of concurrent clients. OFDMA allows the AP to talk to multiple devices at the same time. In the 11ac standard with single-user MIMO, I had to talk to only 1 device at a time. I talked to that first device, shut him off, talked to the second device, shut him off, and so forth. Now I have parallel conversations with both devices at the same time, from 9 clients with 20 MHz up to 74 clients with a 160 MHz channel. With multi-user MIMO, my number of concurrent clients are limited to 8. Range improvement. With OFDMA, I can improve range because of power spectrum density, my butter analogy I talked about earlier when discussing narrowband. Multi-user MIMO does not offer range improvement. Latency. OFDMA tends to decrease latency while MU-MIMO increases latency. Effective ranges. OFDMA is effective at all ranges because of its long OFDMA symbol. Multi-user MIMO is only effective at close to mid-range, so it's not good for long-range applications.